Welcome to this electrifying demonstration of science and technology. Today, we're going to explore how a mini Tesla coil works and why it can light up an LED without any wires. Yes, wireless electricity, right before your eyes. So, what exactly is a Tesla coil? Originally invented by Nikola Tesla, it's a special type of transformer designed to generate high voltage, high frequency alternating current. In our mini version, we start by connecting a DC power source. This supplies energy to the circuit. That energy first charges a capacitor on the board, and when the voltage builds up enough, it discharges through a primary coil, a short, thick coil embedded on the PCB. This rapid discharge creates a pulsating magnetic field around the primary coil. Nearby, we have a secondary coil, the tall copper wound cylinder you see, which is carefully tuned to resonate at the same frequency. Thanks to electromagnetic induction, the changing magnetic field from the primary coil induces a very high voltage in the secondary coil. At the top of this coil, a strong electric field is produced, powerful enough to ionize air and even transfer energy across small gaps. Now here's where things get magical. When you place an LED near a Tesla coil and see it light up wirelessly, you are seeing electromagnetic theory in action. The Tesla coil produces a high-frequency, high-voltage electric field, which induces a voltage across the LEDs leads through capacitive coupling. That induced voltage can be described by the formula voltage equals electric field strength times distance, written as V equals E multiplied by D, where E is the electric field strength and D is the distance between the LED leads. For example, if the electric field is 1 million volts per meter, and the distance between the LED's terminals is about 3 millimeters, then the LED might experience up to 3000 volts at its peak, which is easily enough to turn it on. At the same time, the Tesla coil's changing magnetic field induces current according to Faraday's law, expressed as the induced electromotive force equals the negative rate of change of magnetic flux, which is written E equals negative d phi sub b over dt. This allows even a tiny loop inside the LED to pick up enough current to glow. These alternating fields sustain each other thanks to Maxwell's equations, which describe how the curl of the electric field is equal to minus the time rate of change of the magnetic field, written as nabla cross E equals negative partial b over partial t. Together, these principles explain why the LED lights up. The Tesla coil is wirelessly transferring energy through its powerful, oscillating electromagnetic fields.